Now, example 7.6 obtained equation 7.24 from first principle. Okay, or in exam they can ask that obtained kinematic equation in rotational motion with uniform angular acceleration from first principle. Okay, from first principle means using a integration rule. Okay, using a integration rule, find out a kinematic equation in rotational motion. Okay, already we have discussed a kinematic equation in rotational motion. Okay, we have to derive. Okay, we have to derive a kinematic equation, obtain or derive a kinematic equation in rotational motion with uniform acceleration from first principle means using a integration we have to find out a kinematic equation in rotational motion. Okay, now how to derive a kinematic equation in rotational motion. Okay, therefore first we know that the uniform angular acceleration. Okay, the uniform angular acceleration, uniform is constant, the uniform angular acceleration is given by the uniform angular acceleration is, what is the uniform angular acceleration? That is alpha is equal to d omega by dt. Okay, that is alpha is equal to d omega by dt, or we have to write this is also, that is d omega by dt is equal to alpha. Okay, in that case that alpha is a constant. Okay, that alpha is a constant means that is a uniform angular acceleration. Uniform means constant angular acceleration. Angular acceleration is nothing but a alpha. Okay, we have to define, how to define the alpha? That is angular acceleration alpha is nothing but rate of change of angular velocity, that is alpha is equal to d omega by dt. Okay, now taking a cross multiplication, what we have to find out? That is taking a cross multiplication, d omega by dt is equal to alpha, that is taking a cross multiplication, d omega is equal to alpha into dt. Okay, we have to cross multiply this dt from left to right, therefore d omega is equal to alpha into dt. Okay, integrating the above equation within the limit. Okay, integrating above equation within the limit, within the limit. Okay, integrate this equation, that is integration of d omega is equal to, that is alpha is a constant, therefore taking outside integration of dt. Okay, now within the limits means what is mean by integration of d omega? This is the integration with respect to omega, then we have to put the integration limit, that is the lower limit of integration, that integration with respect to omega, therefore lower limit of omega and upper limit of omega, that is lower limit of omega is omega naught and upper limit of omega is omega, that is lower limit of, that is t, this is the integration with respect to t, therefore lower limit of t is 0, upper limit of t is t. Okay, when t is 0, that omega is omega naught, where t is t, omega is equal to omega naught, therefore the integration is integration within the limit omega naught to omega into d omega is equal to alpha into integration within the limit 0 to t into t. Now in that case this differentiation and this integration cancel. Okay, or integration of d omega is nothing but a only omega. Okay, omega having a lower limit is omega naught, upper limit is omega. Now alpha is a constant, that in that case also integration differentiation cancel, only this integration of dt is nothing but t, lower limit is 0, upper limit is t, that is integration of d omega is only omega, integration of dt is nothing but a t. First put upper limit, then minus lower limit, that is omega minus omega naught is equal to alpha. First put upper limit, that is t, minus lower limit is 0, t minus 0 is nothing but t, therefore this is equal to omega minus omega naught is equal to alpha t. Now this minus omega t from left to, we have to transfer from left to right, therefore omega is equal to omega naught plus alpha t. Now this is the first kinematic equation. Okay, Now this is the first kinematic equation in rotational motion. Okay, we know that this is the first kinematic equation. Now similarly we have to find out a second kinematic equation. Now how to find out a second kinematic equation? Now we know we know the definition, that is angular velocity omega is equal to d theta by dt. Okay, omega is equal to d theta by dt. We know that is the definition of angular velocity omega is equal to rate of change of, that is angular displacement theta. Therefore omega is equal to d theta by dt. Okay, or we have to write also d theta by dt is equal to omega. Taking a cross multiplication, d theta is equal to omega into dt. Now again integrating this equation within the limit. Integrating above equation within the limit. Integrating above equation within the limit. Okay, that is integration of d theta. That theta limit is theta naught to theta. Okay, integration of d theta within the limit theta naught to theta is equal to integration of omega into dt. Okay, that this is the integration with respect to t. Therefore t is lower limit is 0, upper limit is t. Therefore integration of d theta, theta having the theta limits is from theta naught to theta is equal to integration omega into dt within the limit 0 to t. Okay, now here in place of omega we have to put a equation 1. Okay, in place of omega we have to put a equation 1a. Okay, put equation 1a, put equation 1a, put equation 1a in above equation. In above equation we get, okay, wherever omega is present, okay, on that omega we have to put in place of omega, omega naught plus alpha t. Okay, we have to put in place of omega, omega naught plus alpha t. Okay, this is equal to integration within the limit 0 to t omega naught plus alpha t into dt. That is integration within the limit theta naught to theta into d theta is equal to integration within the limit 0 to t omega naught plus alpha t into dt. Now we have to split up this integration. We know that one, that is rule, integration of a plus b, integration of first function a plus second function b is equal to integration of a plus integration of b. Okay, therefore we have to write this is nothing but 0 to t, that is omega naught into dt plus integration within the limit 0 to t alpha into t into dt. Okay, we have to write in that way, that is integration from theta naught to theta into d theta. Left hand side as it is, integration from theta naught to theta naught to theta into d theta is equal to, that omega naught is a constant, therefore taking outside, that is omega naught integration of dt having a limit 0 to t plus, in that case also alpha is constant, integration of 0 to t into dt. Then you know that left hand side integration differentiation cancel, that is theta having a lower limit is theta naught, upper limit is theta. Okay, which is equal to omega naught, integration and differentiation is cancel, that is a t, lower limit of that integration is 0, upper limit is t plus alpha. Now integration of t into dt. Okay, then you know that one rule, that is integration of x to the power n, x to the power n into dx is equal to x to the power n plus 1 divided by n plus 1, means here is a t, therefore its integration is t to the power of 1 plus 1 divided by 1 plus 1. Okay, its lower limit is 0, upper limit is t. This is t to the power of 1 plus 1 means t to the power of 2, means t square divided by 2. Okay, that is omega naught. First put upper limit, that is t, minus lower limit is 0 plus, that is 1 plus 1 2. We have to taking outside, that is 1 by 2 into alpha, that is t square. okay, t square within the limit 0 to t. Okay, here is we have to put upper limit minus lower limit, that is theta minus theta naught is equal to omega naught into t, means that is omega naught t plus half into alpha. First put upper limit, okay, means t square minus lower limit is 0, means only a t square. Okay, now this is theta minus theta naught is equal to omega naught t plus half alpha t square. Okay, also it can be write as theta is equal to this minus theta naught, from left we have to convert from left to right, it is become a plus theta naught. Therefore theta is equal to theta naught plus what is the remaining omega naught t plus half alpha t square plus omega naught t plus half alpha t square. Now this is the second kinematic equation. Okay, now this is the second kinematic equation. Now this is the first kinematic equation, now this is the second kinematic equation. Now we have to find out a third kinematic equation. Now how to find out a third kinematic equation? Now see here, we know that we know that by definition, that is angular acceleration alpha is equal to d omega by dt. Okay, d omega by dt. Now okay, I can split this into multiply numerator and denominator by d theta, multiply numerator and denominator by d theta, then we get d omega by d theta, okay, into d theta by dt. Okay, now we have to multiply numerator and denominator by d theta. Here d theta cancel, then we get same d omega by dt. Okay, therefore alpha is equal to d omega by d theta into d theta by dt. Then you know that d theta by dt is nothing but a omega. Therefore alpha is equal to this d theta by dt is nothing but omega into d omega by d theta. Okay, d omega by d theta. Okay, now taking a cross multiplication, that is alpha into d theta is equal to omega into d omega. Okay, now also we have to write this by omega into d omega is equal to alpha into d theta. Here alpha is a constant. Okay, now this we have to write first and this later. Okay, that is omega into d omega is equal to alpha into d theta. Now how we have to write here? Okay, we know that by definition angular acceleration alpha is equal to d omega by d theta. Okay, multiply numerator and denominator by d theta, means d omega by d theta into d theta by dt. D theta cancel, that is d omega by dt. Okay, as it is. Therefore then you know that d theta by dt is nothing but a omega. Therefore in place of d theta by dt we have to write a omega. Therefore alpha is equal to omega into d omega by d theta. Okay, taking a cross multiplication, alpha into d theta is equal to omega into d omega. Okay, first I have to write this, then I have to write this, means omega into d omega is equal to alpha into d theta. Now integrate this equation within the limit. Integrating within the limit. Okay, now integration of omega into d omega. What is the limit of that omega? Lower limit is omega naught, upper limit is omega. Okay, therefore integration having within the limit omega naught to omega, integration of omega into d omega, which is equal to alpha is constant, therefore taking outside alpha into integration of d theta, that integration limit is theta naught to theta. Okay, therefore now we have to integration of omega into d omega. We know one rule, integration of x to the power n into dx is equal to x to the power of n plus 1 divided by n plus 1. Here omega, okay, in place of x we have to omega, in place of n we have to 1. Therefore integration of omega raised to power 1 into dx is equal to omega raised to power of 1 plus 1 divided by 1 plus 1, means here omega square divided by 2. Okay, therefore integration, this integration is omega square divided by 2, right? That is omega square divided by 2, and its lower limit is omega naught, upper limit is omega, which is equal to alpha integration of d theta. Integration differentiation cancel, that is only theta, that is theta, lower limit is theta naught, upper limit is theta. Now that is half we have to take outside, then that is first to put upper limit omega square, then minus lower limit minus omega naught is equal to alpha. First to put upper limit theta, then put lower limit theta minus theta naught, then taking a cross multiplication of 1 by 2, then omega square minus omega naught is equal to 2 into alpha theta minus theta naught. Now this minus omega naught square, taking from left to right, okay, what you get, omega square is equal to omega naught square plus 2 into alpha into theta minus theta naught. Okay, that is omega square is equal to omega naught square plus 2 alpha into theta minus theta naught. This is the third kinematic equation. Now using the first principle, we have to find out a first kinematic equation. Okay, first kinematic equation, then this is second kinematic equation, and this is the third kinematic equation we have to obtain.